Before we continue, I want to be sure that you have a full understanding of what the name attribute is trying to achieve. So the name attribute identifies each piece of the sim, and that's what we're trying to use to keep track of everything. The attribute is typically a string, and as an example, we might have something like this. So the packed geo, the points that represents the stone, could have a point attribute called name. That's called, let's say, rock001. Whereas if we go down here to, let's say, a piece of the grout, that might be called something else like grout001-1. And so if we break down this naming convention right here, this will really tell us how this scheme works in Houdini. The first section right here identifies what parts of the geo it belongs to. So is it a rock? Is it part of the grout? If you have, let's say, a wall and you have wooden studs versus glass versus drywall, it gives you an overall idea of what that belongs to. The next area, the 001, specifies the first fractured piece. So you go through that first fracture, let's say, and that's the main piece that is being identified. And then sometimes you'll see this -1. And really any number that is dashed like that, that means that's called a suffix, by the way. So if you see suffix, that means it's appended to the end right there. That basically identifies a piece within a piece, or if you are instancing, let's say, multiple windows with the same kind of shatter happening, right? It's a way of saying, okay, here is what this object belongs to, here's the fracture piece, and if there's another fracture within that, or it's instanced, then we just keep on appending additional numbers to keep track of what that specifically is. And the reason why we need a unique name for everything is that the RBD packed object, that requires us to have a unique name for everything. And if we don't, it gets kind of angry, stuff doesn't work, you're going to have a bad day. Now here's a pro tip. This will save you a lot of hassle in the future. The name attribute gets used by many things in Houdini. We have nodes that use the name attributes, we have a for each loop that does it, and we have many things within solvers that look for that attribute called name. Now the thing is, sometimes nodes will look for name as a point attribute, and other times it'll try to find name as a primitive attribute. So if you're not sure, just set the same name value for both the point and the primitive, and you're likely to never run into issues where it's going to, let's say, not pick up the name of something because it was a point attribute rather than a primitive attribute, or vice versa. That's something that you'll run into a lot. Certain things, again, pick it up as a point attribute, certain things are a primitive, and if it's not the correct type of point or primitive attribute, sometimes it'll tell you that it can't find what it's looking for. As we're about to see, this name attribute and keeping track of this is about to become really important. Okay, now on to the constraints. We want a connect adjacent pieces SOP. And before we get too far with that, remember we need to have packed geometry. Otherwise, it's just going to connect all the adjacent points along the polygons. And that results in a lot of constraints. It's not as ideal. So let's create an assemble node to make packed geometry out of all those pieces we just generated. So click packed geometry, and now this relates to the centroids. So turn up the search radius so that we're gathering pieces from all over the place, and the max connections to about 3 or 4. I'll call this our grout constraints right there. Okay, and we also want to bring in the stones. So we'll go right there with the merge, all the way back up here with the stones, and bring that in. So let's keep ourselves organized, not go too crazy here. There we go. Now we have the stones. That's coming in with the grouts. When this connect adjacent pieces goes to connect everything though, it might be a good idea to separate the stone constraints from the grout constraints. In this case, you probably could get away with just doing the constraints amongst everything like this. However, just for your own knowledge, let me show you how you can do that. Again, what I'm trying to do is I want constraints that just exist within the grouts, and then I want another set of constraints that connects the stones to the grouts. And I want that to be two separate things. Maybe you want different strengths for the glue or something like that, right? So in that situation, you would want to create two connect adjacent pieces. And this, let's call this the stones constraints. So we have two kinds of constraints going on. And the way we're going to differentiate these two things is through something called a cluster. And so a cluster is something that you can use with connect adjacent pieces. It basically allows you to define an entire region that is able to connect with an entirely different region. It's kind of easier to see visually, so I'll show you the main idea. Let's say that we have a color right here, and I plug this in, and also on the assemble, let's transfer our groups. So we'll have the grouts right there, and I believe we also have stones. Yeah. Okay, so what we're essentially trying to do is if I had, let's say, a color for the grouts that's red and a color that is blue for the stones, this could represent, visually speaking, two clusters, two general regions that you are allowed to create constraints between. And so that's what we're trying to do with the connect adjacent pieces. We can do that through this boundary constraints option right here. And so you can do that with color. You can also do that with whatever attribute you want. It just needs to affect the same value amongst all the stones and the same value amongst all the grout to group them together via some kind of attribute. So let's go ahead and create a primitive wrangle. I believe these operate on a primitive level. They might be point, we'll see. Kind of winging it here. But let's say we want I at cluster. And this can be an integer or a string, by the way. I means that this does not have decimal values in it. So cluster is equal to 1, and we're going to run this over the grouts. Okay? We can do another wrangle that is, let's say, cluster number 2. And this will be stones. Now, if we go to find the boundary connections, we can choose this cluster attributes, and that will just look between those two clusters when making the connections. So now if we want to do the grout constraints, well, let's actually switch the names here. So this guy, we'll call this our stones constraints. So we'll say stone constraints. Over here, grout constraints. So not affecting the stones, we can just use a blast and get rid of those stones before making those connections. So we'll say blast, get rid of the stones. Now we just have the grouts, and now we can just focus on those constraints. If we then merge these in, so we go right there and there, now we can bring this into the second input of our DOPNet. And then last but not least, we also want to include a primitive wrangle so that we can affect the constraint name, and we can identify these within DOPS. So again, that would be a string at constraint underscore name. Has to look exactly like that. In quotations, we'll call this one our grout constraints. And then copy that. Same deal over here, except we'll call this our stones constraints. So we just say stone constraints. In the next video, let's continue on.